Um, do, 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 do. Okay, so more complex setting. And I was thinking about doing Laurent. I mean, they have a whole section on Taylor series without even getting into Laurent series. What do they do in this section again? Oh, right, Taylor series for a complex number. Or what happened when you are analytic in the entire region. Zach, hello. Hope you're doing well. Um, oh yeah, this is a way of thinking about uniform convergence that I'm not used to. But yeah, this makes sense. Now again, Phobos, hello. God, the Agent Chody Banks emote is too good. Differentiated termwise to obtain a uniformly convergent. Uh, wait. Something's not right between these two theorems. I feel like they should be they should be switched around. Like 3.2.4 should come first. I guess they don't really. They can be proved independently of each other, I guess, but I don't know. Um, my plan was to go to the section on Laurent series and do some problems from there, but I just wanted to scroll through the Taylor series section and remember what this part was talking about. Oh yeah, it's where they first talk about analytic continuations. Since the analytic is not identically zero in some domain D containing z equals z naught, then its zeros are isolated. Yeah, the isolated zero theorem. Remember color code calling this. Hey Lucas. Oh my god, I didn't expect you to be here. Because the stream is so late for me, but uh the short answer is no. The long answer is it depends what you do with math. It's a really general degree. If you get into like academia, you can probably get paid a living, but not an especially good one. If you try to get into industry, then you can get better pay potentially. I personally had a very difficult time finding a job with my math degree though. Yeah, and especially since you're more interested in the theoretical maths, that's harder to kind of not do academia with usually. Um, so it's probably like, oh, academia is like if you become a professor or like a researcher, like you just teach other people how to do math. And when I say industry, I mean just like a normal job. That's just not like particular to a university. Um, but yeah, like math is like almost a little bit too general for its own good if you're trying to get a job with it. It definitely says that you have like an analytic mind and you can like make an argument that you would do well at certain jobs, but like usually specific jobs are looking for more specialized degrees in that job, is my experience at least. Yada yada yada. 2,600 netto per month? Is that something different than a euro? Or like 2,600 net? As in like what you're getting after taxes? I mean, well, okay, yeah. Then I, I guess whether that's good or bad pay depends on where you live. You couldn't live where I live with that, but there's still a lot of America where you could. But yeah, for you where you live, I don't really know. It's 3,000. Oh, I mean, if that's the average of the entire population, that seems pretty good for a starting amount. Yeah, I was just looking at problem two with this. I don't. I was trying to remember if we did the sine of z over z one. Because we definitely did something for number two during the reading group. Can I find this quickly? What is this? 3.2? I found it quickly. I mean, they're series. Yeah, that's true. Shug, what did the triangle say to the circle? What? Ugh. Oh yeah, we had a whole discussion on this one. Oh yeah, sine of z over n. We had to call in Slim, and then Slim got confused, and then we had to call in color cone. This one is actually worth revisiting, I think. But I want to. That'll be for another time. Uh. Okay, we did do sine of z over z. Wait, we didn't do sine of z over z. Oh, it's gonna take too much time. We skipped it. Okay, so. Okay. You're pointless. I'll give it to you. Hope you're doing well, Shug. Hey, famished. Yes, but no. For the amount of money you make with math degree. I mean, I don't know. Like, I guess I don't know what the cost of living is like over there. Like, um, that was all right, Shug. I'll give it to you. You know what? I actually heard a dad joke today. Man, it's not as good without the picture, but basically, I was in a bookstore and I found a book of Star Wars dad jokes, and so I just opened it up to a random page, and oh shoot, I believe the joke was, why did Leia hate Hoth? And then the answer, because she froze her buns off. And there's a picture of her with like the buns in her hair with like icicles. I don't know. It was really funny. I thought it was funny. It's better with the picture though. What is this, rocket science? This is complex analysis stuff, famished, like complex numbers plus calculus. You love them shit like that? Hell yeah. Isn't a circle either completely pointless or completely useless because it has infinite points? Yeah, it's kind of like a matter of opinion, but you can definitely, like, you can show with math that a circle, well, the right way of saying this is a polygon with infinitely many sides approaches a circle. That's still a little bit inaccurate, but basically circles are infinite sided shapes. You could think of it that way, as like the headline. Actually, should we do a warm up, because D is going to be hard. Let's look at A first. A is pretty straightforward, I think. Is it straightforward though? Yes, it is. Actually, it's a little bit too straightforward. It's just gonna be Z to the 2n. So show with math that 0 to the 0 is 1, but mostly a limit, not with the exact number. Yeah, I mean, it depends how you get to 0 to... I mean... It might depend exactly how you get the 0 to 0, how that comes up, but I think it often does become 1 in the limit. A point has infinite curvature. Does it? So I know very little about curvature. Like, you're talking about, like, they usually call it kappa, right? Let's look at the definition again. Good old Paul. We need Paul. His explanation of curvature is really, really brief, though. Might be a little bit too brief for what I want here. A line has 0 curvature. The curvature of a circle is 1 over r squared. Why would a point be infinite? I guess I can imagine, like, wrapping back up on itself. Wikipedia usually has some neat, like, visualizations. Whoa, what is... Oh, this isn't, this is like the idea of being curved. It's not... the exact thing that I want here. Seen someone prove that 0 to 1 is just many numbers, 0 to 2, but by that logic R is the same as C. Yes, it's true, 0 to 1. Well, does it? Is it true? I want to say it is true that the interval between 0 and 1 has as many numbers as 0 to 2. They're both uncountably infinite. But I think R is still different from C because C is basically two-dimensional and R is one-dimensional. So there's some shit I'm not prepared to finish. Uh, that's the penalty for making a math joke around here. We actually analyze it and start talking about math. No worries, Shug. Thank you for popping in. I appreciate you. Don't know what that means. Cardinality is size. Size is in the number of elements in that set, not the width. I forgot I had that alert. Thank you for the bits, Shook. Oh my god. Thank you so much. Peace out. Does it hurt? I think it would hurt. I just think about that video now. It's so stupid. Why was the mathematician late? Why is that? The bijection is 1 over x. Oh, for 0 to 1 to 1 to infinity. That makes sense. You've only seen the start of the joke. I see what you mean now. Okay, so the sharper the turn of the graph, the greater the curvature. Oh, so if okay, I can kind of imagine why a point is infinitely curved with seeing this graph. I think. I said both because he was signed and because he was tanning. FA Minesweeper? We can do a Minesweeper. I haven't done a Minesweeper in a second. I usually do intermediate. Oh, wait, no. No guessing. You better. Usually I'm my own worst enemy in Minesweeper because I try to go too fast for my own good and I just misclick. That's how that's my runs usually end. Fuck. Okay, that time it wasn't a misclick. I got it wrong. You're going to sleep? All right, Lucas, sleep well. Oh, dude, I'm asleep. I need coffee too, apparently famished. My excuse is that I've been out all day, hanging out with family. I have proof too because like actually I don't know if it's easy to tell, but I think my skin is slightly red from like being in the sun for more than 5 seconds. Almost there. Yes, okay. You never understood the logic of the game? It's kind of stupid. It's not a very good game, to be honest. Besides, I was not informed I could apply for a joint appointment as early as this coming academic year. Could have been teaching calculus for fall and spring, as well as just mechanics. Oh no! That would have been cool. My husband water all day must be picking up a bug. Maybe. For me, like like air conditioning really bothers my eyes. Whenever I'm somewhere where the AC is too high, or even in my car, my eyes just like start watering. Okay. Already applied for the next academic year. Okay, that's good at least. Wait, no, that's the academic year after the next. Dang, you have to apply far in advance. Wait, not B. Kosh is kind of weird because they give us the Taylor series. Maybe the exercise they want us to do is to do it from the exponential definition. And so Kosh, e to the x plus e to the minus x because it's even over 2. I gotta fact check this. Yep, okay. Zach's my fact checker. Thank you. Okay, and then we can plug in these two series for e, which is x to the n over n factorial. Yeah. Plus 0 to infinity, and it's a negative x, and I'm going to split out into negative 1 to the n times x to the n, or n factorial over 2. Only $60 a month, so not bad for Coursera. I have a friend who did a lot of Coursera, and he liked it. For someone like you who's like really self-motivated, it's probably a pretty good idea. Which, by the way, Famish, I feel like you like, I respect how much you're able to like motivate yourself to like study this stuff. For higher funding positions, the applications for the next academic year, or even due September of the current year. Wow. That is a lot of bureaucracy there. Oh, so okay, yeah, I see how this is going to work out here. That's not just you procrastinating. That's fair. So what's gonna happen is I guess the odd terms are going to cancel because of this -1. The even terms are going to add, and we'll get a factor of 2, but we're dividing by 2, so it goes away. So really, we just end up with all the even terms of this series. So we can express it like that. And that is the proper answer. Yeah, someone who's had, like, not in academia, but as someone who's had to set up application processes and stuff like that, I can understand the temptation to always push the timeline back to accept applications, but it gets really stupid really quick. Like, it's just bad administration. I have to apply for the... I mean, I'm assuming they don't have that many applicants when I say that too. But for like an internal like teaching assistantship like that, I would think there's not a ton of applications. If I got to apply for the joint appointment, I would have been earning 3K plus per month this fall and spring. Oh, dang. That's even worse. So sine of z over z, I think... I mean, we could do the same thing we did up here with the e's. Let's just go straight to using the series for sine, though, because... Well, actually, I mean, is this even that hard of a question? I thought we skipped this one during the reading group because it looked too hard and we wanted to save time. But isn't it just... Oh, wait, why? Oh, no. Oh my god. Who put all these x's here? X is not going to give it to me. Why? Actually, that's more Lil John. DMX also goes, why? I guess. Sine, is sine alternating? I think it is, yeah. Yes. Because the hyperbolic ones don't alternate. Ooh. Yeah, it starts like that. x to the, no, not x, z to the 2n plus 1 over 2n plus 1 factorial. Okay, this one is kind of, do we just not see the idea here when, like, during the reading group? Because this is not that bad. It does kind of become cosine with an extra thing multiplied. I don't think there's much to that. The radius of convergence of this is kind of interesting. Is it though? Why is it? Wait. So it, okay, yeah. This is just a weird. It makes sense. I just need to understand what this inequality is saying. So we're really just not allowing z equals 0 and z equals infinity. Any other z is fine. Z not equals 0 is because of that bad boy right there. Does any series converge at infinity? I would think not. Okay. I don't think E is going to be much different, but let's just do it. Okay. Now the first term in the series for cosine is 1, so we can take advantage of that. And I think we shall. We should and we shall. Or we shall and we should and we shall, yeah. I don't know. I just feel like saying weird things today. And so the trick here is that the first term of this thing is 1. So I can cancel it with this minus 1. So just start the series from n equals 1 instead. And that saves us doing some algebra elsewhere to simplify it later on. Two n minus 2 over 2n factorial. So this series is starting from a negative power of z. Kind of funny. We could turn that into a Laurent series if we just mess with the indexing, right? Because the first, wait, oh, never mind. No, it starts from z equals 0. Or z to the 0. Okay, let's try number f. E to the z squared minus 1 minus z squared divided by z cubed. Okay. Well. I kind of want to split this piece off. I guess I will. Do I want to? Maybe I don't want to. No, I don't think I do. Just like Captain America. I don't think I will. Z to the 2n over n factorial minus 1. Oh. Yes. Yes. Because n equals 0, we get 1, and we have a minus 1. N equals 1, we get z squared, and we have a minus z squared. So let's start it from n equals 2. Z to the 2n over n factorial, and now we can bring in the denominator. And honestly, instead of writing a new line, just do that. Save electronic paper. Don't cut down an electronic tree. Now this one does start, no, it doesn't start with negative power. Damn it. Okay. I keep looking for Laurent series in the section on Taylor series. What's up with number 3? Let's investigate 3, because I remember being intrigued by it. We didn't do it, right? Okay, good. It feels like a Project Euler question, but just because it has Euler in it. I've never heard of Euler numbers before. You ran into those recently, really? Should have just written, yeah. I don't know how you say it, Sech. Probably just say hyperbolic secant, to be honest. It is Sech? Okay. You know, I feel like since you're Zach with a CH, in solidarity with that, this should be Sec, you know? You don't, oh, yeah, that, how would you say that? There's no vowels. But you know what? That's a Googler. How do you pronounce CSCH math? Professor came out when we talked about it in class once. Couscous. I like that. Cosecant. Koth is Koch? No, don't call it Koch. Cosech? I don't mind cosech. Hyperbolic cosecant x. Oh my god. This is radio stack noise. Exactly, Fizzbuzz. Sech for Sech and Cosech. Cosech, okay, yeah, that's true. If you call it Sech, you probably call it Cosech. Hey, Fizzbuzz. Hope you're doing well. There you go. Your ears are bleeding. All the Poles and Czechs know how it's spelled, or pronounced as it's spelled. From like... Clearly, the textbooks, the authors of this textbook don't enjoy having fun, because they just avoided it entirely by going to 1 over Kosh. How do we want to find the series for 1 over Kosh? Because presumably, I mean, we need to determine the... Okay, we probably can't... Part B seems to imply that we're not going to find a formula. Or at least not a simple formula. I guess are the... How do we find the... Maybe we do need to find the formula. Because how do we find the radius of convergence? They're not going to cancel if we try to do the ratio test immediately, right? We're getting en plus 1 over en, and who knows what that is. So maybe we need to find the series first. It's a good problem. Okay. It's exciting. Well, this would be stupid, but my mind is going to doing this type of thing. This doesn't feel right. Um, They suck now. On your voting project, I found some controversy within Arrow's impossibility theorem crowd. Tons of people have made arguments against Arrow's theorem. Okay. Is this clever? This feels like nothing to me right now. You can long divide polynomials. You go double the part B? Okay. I don't see how yet. Long divide polynomials. So I was thinking about also going straight to the series and just having a series in the denominator. I can't say I'm a big fan of this. I don't think I've ever done 1 divided by a polynomial. Does that even do anything? Can't imagine it does. Usually the degree on top is bigger when you do long division. I do think the textbook was kind of, I do think at times it did combine these two ideas. Instead of doing it as a series, it wrote out the explicit terms though. And I think it would do something like kind of, it would keep things explicit. And this is like, I could do this to determine the first 6 Euler numbers. It would take a bit of a mental effort, but it would work. Wait, would this start from 1? Like, I'm debating if I need a 1 plus out here. I think I would. No. clever because if you have an infinite series sum to the k, this is impossible. You oh. Yeah, okay, this is like I'm going to the same place with a different. Yeah. You know, I could have continued this work and gotten to the same stage here. Um, Wait, I'm forgetting a minus sign. Uh, these are all negative. They're negative Nancy's. I should give some links, but I'm kind of pissed off because most of these people don't understand that voting systems are prescriptive systems. It's easy to say something exists or doesn't exist in that abstract sense. But there's no recognition within the crowds. Um, I guess so, yeah. Talk now? I don't know exactly what you're talking about, but Skirtle math after hours? Yeah, this is very naughty. You know, it's almost 7:30 in the evening. It's nearly past my bedtime. My mom is going to be pissed. Second term should be positive, right? Well, I was thinking, I forgot to account for this minus sign here, applying to all of these terms. That's what I was trying to account for. Did I not do that well? You know what? I think you're right, Fizzbuzz. Yeah, you're right. It gets squared. So then that next one will be a minus. Look at the trajectory of my magic missiles. I don't have to because they just home in anyway. Oh, I think that says fragile. Dr. L, thank you so much for the prime. I appreciate it. Just two more days, Skirtle. And then we'll be firing all the magic missiles. Dr. L, yeah, I played it with Skirtle, and we're gonna have a session playing it on Saturday, and I'm so excited because the game is just it's such stupid but like genuine fun. It is. You have the counter to Rome's TT spell? Wait. What was Rome's TT spell? Oh yeah. Yeah. I remember now. Yeah. Oh my god. Okay, yeah, please. Thank you, Skirtle. I don't want testicular torsion. That was the spell that our friend Rome was jokingly casting on us. What does the fish thing mean again? I forgot. Oh my god. I need to order a truckload of those. I didn't know they even made those. Skriddle sent me a picture of a men's health supplement that's called Super Prostate. My prostate feels very unsuper, I gotta say. Proportional? Oh, maybe. You know, it's about what you never know, Skirtle. What if you like grow a prostate? It might just be like defined or like I feel like it's like defined like we can say these two things are equal because we only care about x's and y's such that that's true. You grow up, you want to grow a prostate. Don't let your dreams be dreams. If that is true, I don't see how you would proceed in the problem regardless. The left side here does look like the result of something of like a binomial cubed. Like, is it 2x plus y cubed? What does this give? Definitely an 8x cubed. Definitely a y cubed. Oh, it is proportional. Okay. Thank you, Riyaj. So you could actually say that x squared plus 2y squared is equal to like some constant times xy. And so if this is true, then prove that is true. Did I do that right? I don't really know if I did. I did not do it right. I forgot the binomial coefficients. I don't know if this is what we want. Riyaj, honestly, problem solving skills just comes from solving a bunch of problems. There's no real way around it. And also, I don't know if you'd want my help because I don't really know how to solve your problem here. I'm trying to think of a way. I'm not quite seeing it right now. I can teach you to Google problems though. That's something that's definitely in my wheelhouse. This is from Quora, so take this with a grain of salt. If you if you're a real OG, you remember me answering questions off of Quora on stream. Oh wait, I probably just doing it on a different browser, but there's a Don Does Math account. Is this the same problem? No, it's not the same. Problem solving flows from the force. Seriously, study physics. True. Aw. This looks like a version of the problem. Is this the exact one? No. Um, what is, man, I really hate that my mind went to, or my eyes went to reading the AI overview. I really wouldn't trust that thing as far as I can throw it. And it's digital, so I can't throw it at all. Riyaj, I think I have to say that I'm not sure to this problem. I'm sorry. I haven't solved a problem quite like this before, and I'm not seeing a way to easily do it. Or difficult ways to do it, for that matter. Keep this up in case something pops into my mind, but I don't think I can. Okay, so I can see how to do part B here. I don't really see how we were supposed to do part A. Part A. Wait, why is my... Is my cam... Why is it like that? I swear I'm not hotboxing. Oops. Wait, I know exactly why it's like that. And why it has that weird, like, spot over here, why it's not. The sun is shining directly at my camera. I don't usually stream this time of day, so I don't usually have that issue. Let me, close my blinds. There we go. Okay, so we can let's get part B done with, that. Honestly, I think the work from here is more clear. I think let's delete this work. Bam. I might need to write out more of this series. But basically the idea is we can figure out the first terms of this series. Those are factorials. Because we know that none of these terms over here is ever going to affect this one here. We know that this z squared here is never going to get affected by anything to the right of it, because this term here starts at z to the fourth, and anything after it over here is going to be even more than z to the fourth. So that's the basic idea behind like how we can get these Euler numbers, the first six. J, I guess? No, K. There we go. So yeah, let's go. Man, 6 is kind of a lot. Let's add one more term inside each of the parentheses here. This is going to help me do some mental math here in a second. And then let's go another term out here. And hopefully this is enough. Okay, so definitely a 1. That means the first Euler number is 1. We have a minus z squared over 2 factorial. Nothing else affects z squared. We have a minus z to the 4 over 4 factorial, and we have a plus z to the 4th over 2 times 2 factorial times 2 factorial. You know, let's just write these out separately. And math them up later. So I'm going to get lost. Nope, 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 no. It's magic. So we have the first 3 that we can get here. This is number 4 we're working on. So we just dealt with z to the 4th terms. Now we want z to the 6th terms. So we of course have a z to the 6 over 6 factorial. Oh. That's kind of funny. This one does not contribute a z to the 6th term. No, yes it does, it does, it does. This times this contributes. Unlike me, it actually contributes something. Do I have to be concerned about... Do I need to add a factor of 2? Because this is squared. Because we're going to have a z squared times z to the 4th. I mean... But there's also a z to the 4th times z squared. Am I just repeating myself, though? You know, let me just... I don't know how to square things. That's what I'm trying to tell the world right now. So we do that z squared times that z to the 4th, but we're also going to do this z to the 4th times that z squared. And there's no other way that we get z to the 6th. So we do need to multiply by 2. Riaz, you put another question in there. Oh. This song kind of sucks. I'm trying to think of a way to do that question that isn't an incredible amount of work. Yeah, I'm sorry, Riaz. The questions you're asking are kind of out of my wheelhouse here. Like, I these aren't questions that I normally have to solve. Oh my god. So I did the Dawn special and I Googled it. This website is really weird. Wow, this is algebra.com? This looks like it was made by an amateur in the 90s. So this solution seems really clever. I just wanted to try to quickly read through that one. I'm just gonna follow that solution though. Bad HTML on Twitch. Honestly, I can appreciate a good old website that's just plain old HTML. But that one is not laid out very well, even with that. A lot of websites now are just like way too flashy. Okay, so Riaj, what the person or what the solution said to do, that's very clever. Let me just rewrite these equations. They said to take these three equations and add them all up. Why did I write a plus sign so poorly? You get x plus y plus z equals 2ax plus 2by plus 2cz. And the clever thing you can do here is that you know if these two sides are going to be equal to each other, then whatever is in front of the x here should be the same as whatever is in front of the x here. So there's a 1 here and a 2a here. So you can just say that 2a equals 1. But by the same logic, you can do 2b equals 1 or not 2b, and 2c equals 1. So you're going to get the same result for all of these. It's just 1/2. And then you can do a half over 1 plus a half plus a half over 1 plus a half plus a half over 1 plus a half. Make it look like a letterhead? Yeah. What is this? This is 3 over 2. A half divided by 3 over 2 is a third. That is beautiful. So you just get 1. There you go. Okay, we do get 1 more z to the 6th term from u getting cubed. There's a minus from there. Okay, so that's, man, it's gonna be a lot of work to get these last two. I don't see how else you can possibly do this. Oh. Sorry. It's been a long day. Okay, so we need z to the 8. And it's really super duper interesting thing related to this, really. The series expansion of 1 over secant x gives the Euler zigzag numbers? That is the most fun name for a sequence that I've heard. Euler zigzag numbers. The inverse Gudermanian is used in celestial navigation. Wait, the integral of 1 over a secant? As in cosine? Wait, is 1 over secant just cosine? Oh. Okay. Honestly, Riaj, I don't really know JE math. So I have a hard time answering that question. JE is kind of its own beast. When n is the even number, it's known as secant number. If it's odd, it's tangent. Oh, show me the tangent. Well, there's a tangent there. That's not the tangent that I want, though. Dr. L, JEE is a very difficult, or the JEE Advanced specifically is a really difficult university entrance exam in India. And there's quite a few people over on YouTube who are always asking about it. And I've tried to solve them many times before, and it's type of questions that rely on vague tricks that no one's ever heard of. And so at some point I just got frustrated and I just kind of stopped doing them because it's just kind of completely different than the stuff that we have to do here. So this is technically analytic combinatorics. I guess it would be, yeah. Actually, at the bookstore that I was at today, I saw they had like a science section, and just out of curiosity, I was like, okay, what does like a random bookstore have for math books? I'm from America, Riyadh, and so I went and looked, and I saw like also like math without the numbers, or like math with bad drawings, or kind of like math books that are marketed towards people who don't like math. But then I saw there was a note that said, if you want textbooks, go to the math hardcore section. And so I went to that section just a few shelves over. The hardcore math section, there were like 6 books total, and they were all like oh shoot, I'm gonna forget the actual term now. It was something combinatorics. Like some really difficult version of, even more difficult version of combinatorics. There's one on Riemannian geometry. Oh man, what was it called? I don't think it was analytic combinatorics. Algebraic combinatorics maybe, or something really grad school niche sounding like that. But it was like 6 books total, and they were like super difficult sounding. Like impossible math. If you want the math that makes you blush, go to the hardcore math section in the back. True. Gold. I am the hardcore math section. I don't know. I think I usually tap out of the hardcore problems as quick as I can. Hope you're doing well though, Gold. I started to read this and then I stopped. I didn't actually read this first part, and I got kind of lost in the later part. You saw the OBS update hate and had to drop it. Yes. I won't have the option in grad school. Yeah, true, Zach. You're right. I mean, there's only 4 classes I'm required to take, and then I have like, it's like 9 electives or something like that. But yeah, no, Gold. Like the OBS update, it just would not function on my computer. Like every time I started up OBS, it just would stop responding. And so I had to like go to their website and figure out where the old versions are posted and go back to the last one. Thankfully, it doesn't delete your scenes when you uninstall OBS unless you select the box to make it do that. So I didn't have to like recreate any of my scenes, which would have been a huge pain. You're returning yourself too? Dang, yeah, I know, maybe it's just a bad update. You had to remove inputs using the JSON file? What? That's crazy. Oh, I get why this is okay. I get what this permutation is doing. So you have to alternate less than greater than or greater than less than. Why these all start with less than? But these things, they flip every time is the point. You can't share your PC screen due to 31.1.2. Wow. Back everything on Dropbox. Oh yeah, that's smart. I should be doing that. You go to Windows 11 too. I did go to Windows 11 only because there was a bug fix for OBS's audio application capture. It was giving me a lot of issues on Windows 10, and the bug fix was only on Windows 11, as far as I know. I need to change up the music. This playlist has played one too many songs that I don't like. You know what? I haven't played this album in a minute. Okay. We have penguins. 2 hits cemented in my memory. Yep. We all saw penguins. That's how it's going to be remembered. By the way, guys, I posted in my Discord, but today I saw sea lions. They're just like chilling out on the wharf, like underneath it. It was funny because like you can't see them at first because they're underneath you, so you just kind of hear like the or. Oops, I clicked on something. From super and like you can't see like why, but yeah. Smelly, cute, fat boys. uh, I mean, I didn't get close enough to smell one, I guess. Maybe that's for the better. Also, I see you posted something, Fizzbuzz. Let me open up your links. Skip the line, but who was Guterman? Has him come up while surfing? Oh, that's awesome. Kind of bastard, I bet. Like they bite, right? Like you really don't want to get bitten by one, I think. Like they'll do damage. I sure don't know this number. It's a very particular number. Sometimes it's fun to play around with the darn things. Yeah, let me just control F Guterman. There we go. There's a Guterman mention. Okay, this is the line. Who was Guterman? He's the guy they named Gutermanian after. That checks out. We're right here. Gutermanian is... The Gutermanian view is 2 arctan e to the u minus pi over 2. That sure is a function. Work out its inverse function. ln... Ah! Okay. Integral secant. Wait, I didn't have to learn this for freshman calculus. Guess I don't think I did. It's an annoying one. It's a sort... Really? So this is what Fizz was talking about it. Distance... A point at latitude GD of u has distance u from the equator in a Mercator projection map. Point at a latitude. Why is that helpful? Because you can just... Oh, okay, yes. Because you can get the height above the equator by taking the latitude and plugging it into this. Hey, fun shorts. Interesting. Oh, his advisor was Gauss. Holy crap. Seems to have been one of Gauss's worst students. The other 4 were Bessel, Dedekind, and Riemann. That's some stiff competition. History of the Mercator. Wow. I had no clue that it was a major outstanding maths problem. 1569. So calculus hadn't been around for long. I think it was invented right around 1500? Question mark? Without calculus. Huh. Newton wrote the... Oh wait, around 1600. Never mind. There wasn't calculus yet. This is cool. I just looked at the scroll bar. The article's a little bit too long for me to want to read it right now, but this is interesting. Because I had no idea that was like a significant thing. Teach me combination. If you want, you can post a specific problem, fun shorts. That's a little too general though. The SMBC comic. Oh wait, I saw that get mentioned. How math works. My god, I wonder if this is true. Resistance, impossible, insane. It's not just incorrect, it's an entirely new category of stupid. Debate. It looks right, but it can't be right. Perhaps we could restructure all mathematics in a way that makes it wrong. Additional decades of debate. You say, I don't recognize this. I say your mother's a whore. With loathing the faculty of Cambridge. Oh my god. Changing of the guard. Never to say it, I'll never believe it. So going to death with my final breath, I spit on your theorem. How do you not get this concept? Spent an hour on it yesterday. True. Ugh. Like the axiom of choice, or like Cantor's diagonalization, I think it's like come to mind for stuff like this. It's funny. Oh, spoiler alert. Oh, is that the idea? Should I? I don't think that's the idea. Is it the idea? Yeah, that's what I'm going through my head. That's what you wanted to do with the polynomial long division? Because I really don't want to do this for z to the 8 or z to the 10. Let's go down that avenue. Oh my god, is that Cook in the YouTube chat? How's it going, dude? Just use the geodesic equation. Dude, you need to go back to the year 1600 and blow everyone's mind with that thing. You actually meant... Well, I didn't know what to divide when you said that, Zach, because there's a 1 in the numerator. Where my mind is going now is to put these into series and divide those series. Maybe that's not what you meant. I'm surprised you haven't talked about waffle stomping yet, Cook. I'm proud of you. You're overcoming your waffle stomping addiction. This is kind of... I don't like this. This scares me. maybe it's okay. I'm getting excited? Yeah. I'm very nervous about it, but I'm also excited. I have sold and gotten and I sold and recycled mostly an incredible amount of my stuff to make the movies here, and I'm still working on it. Thing problem. I definitely was not getting those Fizzbuzz, so. Oh wait, was I getting those? If we include like, oh, it's just z to the n, not z to the 2n. I'm theoretically already done. Oh my god, I didn't have to do this at all. 2e to this. Oh. Well, this is gonna be a really messed up geometric series, right? Like, you're saying to make this piece here into a geometric series? That sounds... Oh, never mind. That's what you mean. That seems reasonable. Yeah. Oh yeah. I'm sure that'll go well for me. I'm so good at integration bees. Fun shorts, post an example of a problem. Otherwise I can't really help you. And even then, depending on the problem, it might be beyond me, but that's pretty clever, Zach. This would give us a series representation. Or it does. This is just it. It's not the nicest series I've seen. And we need to figure out a way to get into the format they're asking for here. You must lurk. All right, sounds good. Fizzbuzz, enjoy the lurk. I do like that though. Fun shorts. I have been talking to you. I need you to post an example of a problem. You know, Cook, I think you're right. I think I do need to assert dominance as early as possible. Down, down, down. Down, 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 down. I'm sorry, it's difficult for me to help you then, Fun Shorts. Because I don't really know exactly what you're talking about, like exactly what you'd want to hear about. And if I can't see an example of a question, then there's just not much that can be done. Because that's a 12, that's a 4. No, that's a 24. That's a 4. So 6. So we get 5 z to the 4 over 4 factorial. Aha! That's good. That's what Fizzbuzz said we should get. And you know what? I'm going to do one better. I'm going to get the 7th and 8th Euler numbers. Oh my god, just make sure all your integrals are dt, then you assert dominance. Oh wait, for a second I thought you're going to talk about like the dominant convergence theorem or whatever that's called. Very good advice about the integration B. Poor integrators have it rough in the dog eat dog underworld of math departments. That's really funny to me for some reason, Fizzbuzz. This is just a good joke. What is 6 factorial? Under 20 times 6? 720? No? Yes. Yes, 720. I don't know. I've already lost the motivation to do this. You know, you know what? No, I don't want to do this anymore. Dot. So yeah, S was said 1, 0, minus 1, 0, 5, 0. You're sending off to another dean until you've talked to 3 people who tell you to talk to the other person. Classic. Okay, so that's cool. How do we do part A? Oh, do we know that one of them are 0? How would we possibly do this first, though? The ratio test is weird with this. Because E sub n is sometimes 0. Okay, see you, Fun Shorts. What is your radius of convergence? How do you find the radius for something that doesn't have a pattern? That seems like a problem. Aw. Oh, look how quickly these things blow up. Wait, there's zigzag numbers. Hmm. Um, the radius of convergence, A. Can we compare it? Hmm. Oh, do we think of it as a derivative of something else? That must be it. It must be, we have to think about derivatives or integrals. ln, is it the derivative? No, it's not. Poles? That would help with the radius. Oh, oh, that would help. There's poles at I and minus I, or is that true? See, I mean, that doesn't give us an upper bound for the radius. It's gonna be like I pi over 2. I mean, so I know that the radius of convergence can't go past a pole. How do we know it goes up to a pole? Do we, is that there's probably a theorem somewhere that you could use to show that? But yeah, I guess poles is the good idea. Okay. And plugging in 0 is okay. Well, it's not technically okay with this thing here because you get a 0 to the 0. I'm going to glaze over that, I guess. And we certainly can't include a pole. I feel like maybe 0 should not be included because of that 0 to the 0. But one over cosh of 0 is defined. So I feel like we could manually define something there. Actually, you know what? Never mind. Just say it's less than pi over 2. Okay. So that was number 3. What else did we do during that day? We went from 2 to 6 to 8. Alright, these are kind of lame. What's up with this one? Binomial expansion and Cauchy's integral theorem to evaluate that, where C is the unit circle centered at the origin. Recall the binomial expansion, where that. Use this result to establish the following real integral formula. Why would you want that formula? Oh, Zach, I don't remember if I said, but good job on Melissa and Denial stream, by the way. I still need to go back and catch the part of it that I missed, but that was cool to see there. Yeah, it was neat. You don't talk Egyptology very often? I definitely don't either. I also don't know the first thing about it. I do remember being taught about Pefsu. I don't know if you guys mentioned that. I think the Egyptians use that as like currency, as like bread and oh yeah, Pefsu. Like 1 Pefsu was like 3 bread or 5 beers or something like that. I can't remember exactly. I'm reaching back to my history of math class. It's a little bit fuzzy though. What's Cauchy's integral theorem again? I feel like I should have this memorized. There's so many, like, Cauchy has his name on too many things. Especially when it comes to complex integrals. There we go. That's what we want. Yeah. I don't like you being there. Where do I want to put you? Maybe you go above. Maybe that's where you belong. Okay. The moose outside with the sign didn't tell me I needed BS in math to be a member of the channel. Hey, Kensai. No, I mean, everyone is welcome. I realize that I'm normally doing crazy math that, like, the average person who doesn't study math won't have seen before, but I don't mean it to be like that. I would definitely talk about like things that aren't as crazy as this. Welcome in though. Um this is weird. So I guess we should binomial expand first. Sounds good. I also play games too, and usually the game streams don't have very much math speak. I definitely understand if people or yeah, just because I like math does not mean that everyone likes it. So most of I'm actually streaming math. I don't usually like bring it up on my own. So this is to the 2n. How does that's kind of cramping my style. How do you binomial expand with 2n? I guess we could take this formula here and just substitute 2n for everything. Am I missing anything? I don't think I am. Whoa. Oh, I gotta switch up the music. Oh, I've had to switch up the music. What am I gonna play now? Well, you know what? I think I know what I can play. Let me find it. Where is it? There it is. Quantum factorial units. I have no clue what those are, but hello. Flebogetsky? Z to the 2n minus k 1 over z to the k. All of this over z. dz. This integral is too small. That's a good size integral. I guess we can cancel these? Question mark? We probably want this over z to stay put. I was about to bring it into the summation, but I don't think that's a good thing. I guess it's 2n minus 2k. As weird as that looks. Okay. And so is this a place where we pretend this is minus 0? And the weird thing with Cauchy's integral formula is that it's presented with like this, but often when you apply it, the z and zeta are switched. Like zeta in this thing is just the thing that you're integrating with respect with, but here we're integrating with respect to z, so we have to switch around the variables, and that always kind of trips me up. But I think the point is that we're going to say this equal to 2 pi I, and since this is 0, this is our f, well, this is our f, right? It'll be this thing with z equals 0? Really? No way. Especially if they're giving us the definition of the binomial coefficient. Like, wouldn't we need to actually expand that? Something's not right. Wait, this is... I made that infinity. This is a 2n. Well, I don't... Maybe we should try a different approach. Maybe... we do one of these. And then we do... one of these. And then we binomial expand this? Hey, collar cone. Yeah. I was out hanging out with family all day. And so I got home at like 6 p.m. my time, 8, and then just turned the stream on. That's what I'm looking at right now. I'm still trying to work out a good approach for it. Yeah, hope you're doing well. This probably won't be a long stream because I'm pretty tired, but I've been going for a little while longer. Hmm. Okay, so if I binomial expand, so I guess my idea with doing this is to use the version of Cauchy integral theorem that involves derivatives. Um, nope. Uh, to the 4n minus 2k? I guess we can do it just to the 2k and its equivalent. Yeah. Is this better or worse or the same? I might be having the same exact issue. Um, this one. Do 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 do. So if I use that version, we'd have to take the derivative. I guess if we can do that, maybe this works. Yeah, I like this. I haven't played this album in forever, or like listened to it. It's pretty good. Um, the album is OP1 by Slacker. This actual song, it's just called Who's Around, but it's one word. Do 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 do. Okay, so we're pretending this is a 0. Ooh, we're pretending it's a z minus 0 to the 2n plus 1. That's the same issue. Um, is it? Should I just believe? Do I have the... Is there a constant term in this? And that's what saves this? When k equals 2n, or when k equals n, we get 1 there. Is that what saves this? The only thing that would survive, so 2 pi I times 2n, choose n. And then that was a 1. Ooh, was that it? Maybe that's the trick I wasn't seeing. That, oh, this looks almost the exact same as this. Yeah. I must have gotten it. C is a closed curve winding once around the yes. It is. I think I just got the answer. I think this is the answer. So the fourth the end, I'm not sure where that's going to come from. I'm just noticing the similarity between this part of my answer and that part there. And I guess I have a 2 pi that has a 2 pi on the other side. This thing down here is slightly different because they're asking about that real integral, and the formula that's supposed to derive to start with came from that imaginary one or complex one. Now this makes me feel like we need to do some type of splitting things up into real and imaginary and equating each piece. This work probably lead to the same thing, but it's no longer necessary. Is there a hidden cosine in here? Cosine goes off to infinity, that series. Or like, is there an exponential in here? Well, I guess we need to take z equal. Oh, maybe we take z equal to re to the I theta. Where do I want to do that? I can half see it because our contour is just around the unit circle with radius 1, and this integral fits that bill. I don't know if it's too soon to just do it to this though. Should I be doing it here? That's what I'm trying to work out. I don't really know. You should have your master thesis submitted tomorrow morning. That is super hype. Good luck. Waiting your advisor for confirmation. Oh, that's awesome. I hope it goes smoothly. Okay, I think we are going to start from this. I think we are. I think we are. What am I going to do? Let's just take is equal to... I mean, we just need to e to the I theta. Nope. Because r is 1. So that z will cancel with that e to the I theta? Is that what you're telling me? Yeah, and we get an I out front, and that's probably a good thing. Is this the complex definition of cosine? It is. With the coefficient. With a... With the 2 missing. Oh my god. Ladies and gentlemen, we have cracked the code. This is 2 times cosine. Wait, what is this username? Reformed Ramos. Thank you for the follow. I laughed because I saw you have Draven as your Twitch profile picture. One of the referees, one of my possible PhD advisors. Oh. After my reading my thesis, he'll still want me as a student. Hopefully. I am having a eureka moment. I feel like I actually just did something kind of smart. If I can actually... I need to actually bring this home. Maybe I shouldn't get ahead of myself. But this 2 can come outside, and it'll become a 4 to the n. And things are coming up Millhouse. So far. Oops. And now we can cite the result that we got earlier. So really, we should be saying 1 over 2 pi. We should have this here from the get-go, because that's what the second part of the question inserted. It's equal to 1 over 2 pi times the result that we got here. And now we're done, nearly. Oh wait, sorry, the 1 over 2 pi stays. I don't know why I said sorry. I didn't do anything to you, but there we go. The 4 to the n and the I come over to party. Bam, I feel good about that one. I'm kind of happy that I could actually solve that. I'm really happy making the realization that only one of the terms of this series survives Cauchy's integral formula. I survived Cauchy's integral formula. Okay, maybe now we're ready to graduate to the Laurent series section. Actually, let's read through the theorems again. It's been a second. Every time I hear that one instrument, I forget what you call it, but it's the one where you have like the wooden like ribs and you drag a stick across it. I think of that one Beck song that uses that too. What is that called? The instrument. I don't know. That's one of the few instruments I could probably actually handle because it's like as simple as a triangle in terms of playing it. You try the ones in elementary school? Oh, nice. At least someone knows what I'm talking about. Okay, you know what? Sometimes when I can't remember the word for something, I like to Google it, like the most vague description possible, and see if Google can still figure out the answer. What is the instrument where you drag a stick across wooden sticks, I guess? Guiro? I guess that doesn't sound familiar though. I don't think it's that. No. I mean, that looks more like it. Scraper? In Swedish, it's cucumber? Wait, what's my notification? If it looks like I've looked at Reddit through this account. Wait, 3 days ago? There's no way someone just replied to something 3 days ago and I happened to check it. Someone did. What? 1 year ago? Tuesday, January 30th, 2024. On stream I used to pull a lot of questions from Reddit and just solve those. Tan x equals tan 42. Wait. What? 90 is less than or equal. God, how did I read this the first time? X is between 90 and 360. What's the equivalent? It's going to be in quadrant 4 or quadrant 3, where tangent x equals tangent 42. I guess you just add 180. That's what I did? Okay, nice. Why am I so unintentionally funny? I'm glad you enjoy it. Why are 2 and 4 negative? So they're talking about quadrants 2 and 4. Flute a Beck? That's just a recorder in English? Oh yeah, these are the things that they give to kids. Fipple flute? Dude, fipple flute is so much more fun to say. Fipple flute. Wait, what is this going to do if I hit play? No! That sounds so bad. One more time. It's a different one. It played something different. Wait, okay. What if I search guitar? It's not showing me. Okay. Oh well. You know, we will reply to this person. We're not gonna leave them hanging for more than 3 days. Your kids play these? I played. Well, I played them in sometime between kindergarten and 8th grade, probably for multiple grades. It did not sound good. Mention our parents to deal with that. I know. It was mostly just the music teacher. I don't think I ever had to practice at home, thankfully. Um. Uh. What's a good way to explain this? You take the y value and divide it by the x value. In quadrants, or in quadrant 2, x is negative and y is positive. So you get a negative tangent. So y over x is negative, and you get a negative tangent. It's switched around for quadrant 4. Quadrant 3 is positive, on the other hand, because x and y are both negative. So y over x is positive. There we go. Most beautiful sound ever performed on a recorder. Is this My Heart Will Go On? Yep. It's about to start. There's a little bit. 39 million views. So bad. Boo boo. 2010 YouTube. Oh, 2009. November 2009, just barely 2000s. Ugh. The acting is better than the movie. I have a lot of tabs. Let's get rid of some of these tabs. Okay. Music. Oh wait, that album ended. What we can do, let's play that song, because it's just a banger of a song. Okay, Laurent series. I think it's really cool that how the starting point for the Laurent series reflects the type of discontinuities or singularities the function has. So like if it's just like a simple pole, it starts from n equals -1, and I think like if it's a double pole, it'll start from -2, and then I guess if it's an essential singularity, that's where you get the infinite. I have to fact check this. Yeah, I gotta say, okay, good. Um, Oh, that's kind of a clever. Okay, yeah. Uh, 144 Amorphous. This is this book here. It's decent. I wouldn't say it's like the best book ever. I'm using this more because a class I'm going to take soon is going to use this book, so I'm trying to study ahead. It's not bad though. It's way more on the applied than the theoretical side, and I personally like that. So the only entire functions that have infinity are polynomials. Everything else must have an essential singularity at infinity. That have poles at infinity? Ooh. Really? That's sort of making sense, but I think I need to think about that a lot. Hmm. Oh yeah, no worries, Amorphous. I'm like starting on grad school soon, so I wouldn't feel bad about that. If you have a question or something you want to talk about, feel free to let me know too. This is just something I do to fill in the time, really. Holomorphic functions that are holomorphic on C and at infinity has to be constant. So the only interesting ones are meromorphic. Right. I remember to be analytic, you have to be at infinity, you have to be constant. What's going on with this one? The Laurent expansion of 1 over 1 plus z for z greater than 1. Okay, yeah, that's why it's a Laurent. Different expansions in different regions, right? Hey, Taratar. Yeah, I don't know if it's the first time. It's at least very rare. Um, this song, oh yeah, I really love this song. It's called Be With You by Fade to Black. Wait, I'm trying to get the spelling right. Fade to Black. Yeah, okay. And there's also Astral and Genie Cassini. Astral, Genie, Cassini. I think I got that from one of my playlists I listened to on stream, but I just legitimately really like that song. But yeah, I was out with family just hanging out all day. And I would have streamed math today. So I just kind of decided to do it once I got home and got some food. Oh. Oh yeah, this is where it got really weird. Because I'm not able to figure out the math I did in one of these steps. I remember not being able to figure out one of these steps. But the first two non-zero terms of the Laurent expansion obtain z about z equals pi over 2. So they do a change of variables, which seems sensible. Then they end up with minus cosine over sine. They take those expansions, plug them in. They factor a u out of the bottom. And then they say the denominator can be expanded via 3.3.27. What is that equation? Yes, they call it a geometric series. But the way they used it makes me deeply uncomfortable. Because I think this should be a minus. If you can call that deep discomfort. Wait, why is there a 1 plus? Am I missing something? Wait. What? What is this? Witchcraft. Oh. Oh my god. I know pi over 2 is a singularity of tangent, right? That's cool. What is the context of this class? That's a good question. So, before taking this class, you would want to take classes in single variable calculus and multivariable calculus. At least one semester of, or at least like one introductory real analysis class. And then you'll be okay. Basically, the idea of this subject is you take calculus and you throw in complex numbers. And that being able to use complex numbers can make many things easier in the real numbers. So I've gotten through chapter 4 of this book, and you can use complex numbers to evaluate real integrals that are otherwise very difficult. So like you can integrate cosine over x squared plus something squared. That would be if you've only ever taken a regular calculus class, you would not have the tools to figure out that integral. Unless you want to use series, but that even that's going to be very messy and painful. But yeah, so that's basically like what the subject tries to do. Basically make calculus in the real numbers easier by including complex numbers. Another good thing that comes from these are Fourier and Laplace transforms, and these are really helpful in all sorts of like engineering type of things. I still need to read this part here. I don't want this song. What do I want? What do I want in life? There we go. I've got 7 or 8 songs in queue. Well, maybe once we get through that queue, I might end it. What am I doing? Okay. Yeah. Oh yeah, I was trying to figure out this stupid example. I don't know, man. Does not make sense. So let's just move on to problems. Oh. Reformed Ramos, welcome in. We're really given... Really? So... The part of that that I have trouble believing is that, like, you say to only consider this part of the denominator, but we don't get to just ignore the other terms. Like, they're still there. And so saying that like this is equal to u squared over 3 factorial to the n as a sum just doesn't seem right. Like, I don't think we're allowed to just forget about all the other terms. So, I don't know. I appreciate you even engaging with this. And you could very well be right. Show up after that series. The question is a good one. I believe all types of series converge uniformly. I need to see some more justification if something like that is allowed. But yeah, I mean, I definitely think that I'm the one who doesn't understand the book, and the book is probably right, and that you're also probably right. It's just a very it's not a thing that I've. If it is what you said, I definitely have never seen that before. Yeah, fair. 5 could be cool. I'm just learning stuff for the first time, basically, so. Although this type of manipulation isn't necessarily complex analysis. I feel like I could have encountered that somewhere else, I just haven't. Is that a T up there? That is a T. Talking about right there. Set W equal to U squared. Is that it? Really? That's the justification? I need to write this out. So, continuing on from there. Get out of here, Bessel. With your function. What we're doing... We're saying... Or I'm going to boil down to just this piece of it first. Just to make life simpler. That looks like a 4. We're taking W equal to U squared for 3 factorial plus dot dot dot. So we get 1 over 1 minus W. Oh, this is a terrible sigma. I'm keeping it, but that's a terrible sigma. W to the N. The sign gets flipped here, right? Wait, yeah, that's now a minus. That's fine. And so the first term of this thing is definitely 1. And then from the W to the 1, we get a U squared over 3. And so, okay, this is only helpful because they only want the first few terms. First 2. Okay. I hate it. And yeah, Ramos, I think that's kind of a good point that, like, finding the first 2 non-zero terms isn't very impressive, I don't think. Okay, well, thank you both for clearing that up. Let's see how far we can get in this one. This might be a doozy. Amorphous. JE is it's a university entrance exam in India, and it's very difficult. Pretty frequently I have people on YouTube come and ask me questions from that, and I wish I could do them, but I've tried many times and I just can't. It's way different from the tests that we have here in America. They use very weird tricks that are just like very vague. So I don't really know how to do the questions, and I really don't like doing them because I don't find them interesting. Bessel function plays the role of cosine and sine function on the spherical domain? That's kind of sick. I didn't know that. You can do Fourier series on a spherical domain, but instead of having cosines and sines, you have those? That's crazy. Bessel for what? I never a Fourier sphere series on a Fourier series on a spherical. A Fourier series on a spherical domain sounds wild. The stuff you can't solve. I know that I could do them. I just kind of don't want to. Okay, I'm not gonna pretend to know what all this means, but it's kind of cool. You do that when you want to solve the heat equation such way because of the spherical boundary condition. That's really cool. Yeah, Carl was just tell me about this Fourier Bessel series thing. That's a Fourier series, but with spherical coordinates. Oh yeah, PDEs is going to be third quarter. Maybe also sooner if I did an extra class in them too or something. But one of the required classes is PDEs. I was like, the first quarter, the required classes applied complex analysis. Second quarter is ODs. Third quarter is PDs. So the only one I feel like I'm remotely confident about is ODs. But even then, I know this won't be easy. Like, it can really grill me. Oh, really? Well, hell yeah. We can have 100 PDE stream. How many PDE problems are there? For whatever reason, I feel like there aren't that many PDEs to solve. I'm sure I must be wrong. But like, I don't know. For sure, I feel like PDEs can't be that big. Like, or like, maybe you can name a lot of PDEs, but there's not a lot of solvable PDEs. Basically, when you apply the spherical Laplacian to those, you just get a constant time times your initial function. It's called eigenfunctions of the Laplacian? That's wild. Eigenfunctions are a thing. Apparently. So e to the x or e to the cx is an eigenfunction under derivatives. That's why we need them for the I assume the wave equation, maybe? They make the Laplacian behave like a good doggo. Oh, the heat equation, okay. I like that phrasing, behaving like a good doggo. Also wave, okay. The simplest eigenfunctions are sine of x, sine of nx, cosine of nx, whose linear combinations form a Fourier series. Huh. What are they staying the same? Or like, what about them stays the same, I guess? It is just under derivatives? Oh wait, that's just a linear operator D? It's not necessarily derivatives. Okay. Or it's not like necessarily a regular single variable derivative like I'm thinking of at least. Okay. See the derivative example below? Okay, so exponential function is an eigenfunction for the derivative. Yeah, for like the regular old derivative. Okay. Is that a convolution? No, complex conjugate. Never mind. You can always find function instead of eigenfunction that satisfy those conditions, even with a wonky domain. That's the spectral theorem. So, you know, I've heard of the spectral theorem. I've been introduced to it just through a regular linear algebra class. I didn't know. Well, actually, I guess. Okay. That's weird, but it is the same. Yeah. Huh. Yeah, that's crazy. I remember like when I was watching the Strang lectures on linear algebra, he was talking about how the spectral theorem is this really huge idea. But just having been introduced to it, it's kind of lost on me. That's really interesting to hear that it extends that far to like eigenfunctions and stuff. Uh, a billion partial differential equations upon ye. That sounds like a curse. Having an orthogonal basis that diagonalized an operator. Yeah. Uh, Nihar, I saw you post something, but I didn't get a chance to read it. Hello, though? That's cool. Um, what am I doing with you, Bessel? Should I be doing this? Show from the definition of Laurent series in using properties of integration. I should be thinking about properties of the Laurent series, or the definition of the Laurent series. It is? Okay. It's chock full of great problems tonight. Okay, so J sub n is just playing the role of C sub n. So J sub n is equal to 1 over 2 pi I E to the t over 2 z minus 1 over z for I guess just z to the n plus 1 dz question mark. I think so. Okay. And so presumably, if we're going to get to the second part, we need to take z equal to probably e to the I theta if we're doing the unit circle. Sort of see it like before complex analysis and integral, like that cosine integral will be hopeless. Now we can actually find an angle to attack it. Like with this cosine integral here, or the one we were looking at before. Oh my god, I did the thing that I always do when I say or, but he said yeah, so I assume you mean the first thing I said, which is that. Okay. Yeah, that one's a weird one. I always do that to people. It's such a bad habit. I pause and then I say or the opposite. Wait, am I thinking about this right? Yeah, I think so. Okay, so if I just take z equal to e to the I theta, what happens? And here I'm saying that c is the unit circle, I guess. I don't know if that's... I assume that's okay. I don't know that it is. Now, they're integrating from minus pi to pi. Is there a branch cut? Or why would you do that? I don't... Oh. I don't think there's a branch cut. We can just do minus pi to pi. We can just trust the process. It's the same thing as 0 to 2 pi, right? So e to the t over 2, e to the I theta minus e to the minus I theta. Maybe we're getting there. E to the I n plus 1 I e to the I theta. Oh, okay. Okay. I think we're not that far off. Because this is t sine theta. And then these are all like base E, the best base. So we can just add the exponents. I theta plus I theta n plus 1. Ooh, by add I mean subtract. Do 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 do. Milk. You love me. Or sorry, you love you. So, some Laurent series. That's awesome. We're looking at Bessel functions. Trying to find this formula here. Okay, so the I thetas do go away. I think I'm nearly there. Okay, that is the last song I had in queue, but I lied. I can't stop now. I was gonna stop the stream when that song ended, but I lied. So I love lying. I need to find a new song to play though. Uh, 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 uh. This has lyrics. I'm gonna play it anyway. I just, oops. Shuffle, play. Not that one though. Yeah, that's okay. Can't stop the math. Can't stop, won't stop. How to solve a 5th degree polynomial? You often can't. You'd have to do it numerically usually. There's no quintic formula. I theta. Oh, you know, Karen Powell's nice. Those two cancel. And then you can rationalize that. So we've done the first part. Wait, minus I. Ugh. I don't think it should. Oh, maybe it should be minus I. There's a minus sign there. So color code the you cannot play any music you don't have the rights to on Twitch or anywhere. You can play whatever music you want anyway, and if it doesn't get saved in the VOD, which I have that set up, if you listen to the VOD, you won't hear the music. You're unlikely to be caught. But it is like you're not supposed to play music you don't have the rights to. Yeah. And so on YouTube, they don't get music either because YouTube doesn't have that same like loophole. I'm getting the wrong sign for sign. Ironically. This needs to be a negative. Or really, I need a negative from even earlier. Are you planning to stream soon? I think I followed you ages ago because you mentioned you might. There are like solutions I was just looking into these for someone else. Um, I'm just pulling up the message I sent that person. So if you do want to play music, there are legal options for like things that are just like put out there for anyone to use. Tomorrow? Oh, hell yeah. Well, everyone say hi to Collar Cone then. Or else I'll come after you. Oh, you've apparently streamed Ocarina of Time before. That's funny. But yeah, so the easiest thing to set up immediately is Stream Beats by Harris Heller. Oh, I mean, at least you set your category to that. Maybe you thought about streaming it at some point. When I was looking into copyright-free music recently, those are the things that I found. I've used the first two myself and can vouch for them. The third one I can't, but as far as I know, it's legit. And so those are all things that would not, and the only penalty on Twitch is they mute the parts of your VOD that have copyrighted music. That's the only penalty, really. Mission from Dog, till you had your game audio track 1, music audio track 2. Yeah, exactly. Yeah, and Colin, if you want any like help sending your stream, feel free to send me a message or ask me here. Yeah, so it's not a big deal. Set up different audio channels to get around it. Exactly, yeah, milk. I mean, I also make it so my browser audio, like any audio that plays here also does not go through, because I sometimes play music through here, or if I watch a video or something. I also have my alerts don't get saved because those use copyrighted stuff too. Oh, I know what I did wrong. I forgot the I in sign. There is no I in sign. Actually, there is an I in sign, and I forgot it. I still have the wrong sign though. Do I not? We'll be waiting till doomsday as long as you're too far away. Wait, I might have the right sign. It's they factor out a negative I. Ugh. Disgusting. There we go. Okay, I have this right now. What? There's only one more step in this problem, which is to get to this step now. Euler's formula. And then evenness and oddness. Minus pi to pi, cosine, and I guess we get to ignore it for cosine. that? Wait. Well, what's the period of this thing? You might rename your Twitch name. My man Collar was not a very nice German during his living. Oh, really? Well, yours named after his cone. Rather than him exactly. But I would understand. Hey, Lizzie. Yeah, if you want to just ask a question now, this is something I'm just doing to fill in time. You learned that recently? There's a lot of mathematicians who just weren't very good people. Big mathematicians don't have a very good percent of being a good person. That's a terrible way of phrasing that, but oh, wait. You have an exam tomorrow, you haven't studied and you're kind of cooked? Oh no. What is it for? Okay. Is this even or odd? Year 8 maths? Okay. Do you want to give me like an example of an example of a question that you're having trouble with, or do you want me to try to explain a concept? How can I help you here? Okay, so this is actually, by some miracle, an even function. It's kind of amazing. And this is going to be an odd function, which means it goes to 0. Called linear equation, you don't know what it is. Well, I mean, it could maybe be a few things if that's the only piece of information you know, but like, if it's just the equation of a line, you might have learned like y equals mx plus b, or sometimes they teach it or they show it like this. But like, are you doing things like you have your x and your y axes and you have to graph a line? Like maybe it has a y-intercept of 1 and a slope of 2. Okay, so yeah, maybe it's this. So if you want, I can tell you what that means, but is that what you want to hear about? This is called like, okay. Yeah. So this is like the equation of line as it's usually taught. So let me write what each of these things are. X is your input, which is anything that you want to give to the equation. Y is your output, whatever you get at the end of this. M is the slope. B is the y-intercept. It's the y-axis. Or equivalently, when x equals 0. So that lesson's a little bit long. But basically, let me go to an actual example. Y equals 2x plus 1. Whatever number is in front of the x is your slope. Whatever number is being added or subtracted is your y-intercept. And so, if you want to graph this, let's set up some x and y axes. The y-intercept means is that's where we know that when x equals 0, y equals 1. X equals 0 is a really easy point to plug in here, so that's why we talk about it a lot. If x equals 0, y equals 2 times 0 plus 1, and that's just 1. So we know the point 0, 1 is on this graph. So I'm going to draw that. And now what the slope means is that is the steepness of the line. Like a 0 slope is a flat line. I should just draw it. 0 slope is a flat line. And if you had like infinity slope in quotes, you'd have a vertical line. Here our slope is 2. And so how that gets reflected in the graph is, you know what? I should have chosen a better example. I'm sorry. I'm going to edit this. I don't want to use 2. There's a better example that I can use. I'm going to use 2/3. And that's going to be for reason that you're about to see right now. So I'm using a fraction here because it's easier to see this next piece, which is slope is rise over run. So m your slope is equal to rise over run. And that's just like a little mnemonic to remember what this means. If our slope here is 2/3, it means every time we go up 2/3 on this graph, so 1, 2, we run to the right 3. So we know another point on this graph is right here at 3, 3. And so now that we know those 2 points, we can just connect the dots with a line, and that's our rough graph there. I could also go to the left. I could run to the left 3 and run down by 2 and be on the line also. And I could repeat that as many times as I want and still be on the line. Same with going up and to the right. So yeah, that's the most important thing to know about y equals to mx plus b. M is your slope, which is rise over run. B is the y-intercept, which is where you hit the y-axis. A good thing to see with linear functions is just to make a table of x and y values also, and just look at that trend. Oops. So let's say I want to plug in these x values and just see what we get out, and just look for any trends. So if x equals 0, we already said y equals 1. If x equals 0, I'll do this fraction math for you. We get 5/3. If x equals 2, we're going to get 7/3. There's a better example I could have chosen still here, because it's going to be a little bit weird with the fractions now. If x is -1, we get -1/3. If x is -2, did we get this? Am I so fast? It's just a lot of practice. I messed this one up. We get +1/3 there. I'm a person who's like specifically studied math for for years, so I've gotten fast at this stuff. Don't feel bad if you're not this fast. And then minus 1/3. And so the thing to notice with this X and Y chart is that these X values are only changing by 1 each time between each row. And these Y values are changing by 2/3. And the important thing for a line is that this same thing, this amount of change is true for every two, or like, this change is the same throughout all these rows. Like, if you want to choose any pair of these, it's always 2/3 in Y's and always 1 for the X's. For other types of graphs, that is not true, but lines, that's particularly true. Exactly, yeah. That's what I was doing in my head. So to do, like, for X equals 2, I did Y equals 2/3 times 2 plus 1. So 4/3 plus 1, and then you make the 1 into 3/3. Yeah. I'm glad to hear that. Awesome. Well, thank you for the question. If there's something more you want to hear about, let me know. But yeah, that's like the important things to know about a line if I were to teach them about them for the first time. In the meantime, I'm gonna go back to this problem just for a little bit, but I'm always happy to like switch right back over. Actually, I'm basically done with this problem. Yeah, that's actually only one more line. Oh, don't worry about this stuff. This is like late university level math if you major in math. You will not have to do math like this unless you really seek it out. I'm gonna be starting graduate school soon for math, so I have to learn this crazy stuff, but this is really only for like math majors. So if you don't plan to do that, you don't have to worry about this. I think it's fun, but yeah, it looks crazy probably. But yeah, let's see. If you're gonna ask anything else, let me know now, because I think I'm gonna wrap up the stream here soon. If not, I know, FA. I'm a complete sicko. And like Bessel functions, well, you know, what kind of deranged person enjoys those? Wait, no, I'm not trying to be mean to you, Lizzie. Sorry, that wasn't my intention. I'm sure trying to tell you, like, oh, the other person. No. FA's a friend. She's just giving me crap because we're friends. But yeah, I'm probably gonna wrap the stream up here. So unless you ask me a question soon, Lizzie, if you do have one, I'm gonna wrap it up. Make some better repo. Friends saying them? Oh no. no one's dumb. It's just, or like, math is hard. You're not dumb if you don't get it. I don't get math all the time. But yeah, no, Repo is a video game that F and I play. It's fun. If you ever need more math help, by the way, Lizzie, there's a couple of other people on YouTube who are friends who do a similar thing. Hopefully this command works. Yes. So Academy Uses Ideas and Actual Education are both people who could like help you out too if I'm ever not around. Yeah, I think that's gonna be it for me then. So yeah, Lizzie, and also here on YouTube, thanks for being here. I'm not sure when I'll be back streaming math. Actually, I'll be back on Tuesday, but I don't know. I might even be streaming math tomorrow. I'm not sure. My schedule's up in the air, but I'll stream math again at some point. So yeah, goodbye YouTube. On Twitch, we'll look for a raid.